Introduction to Logarithms. Logarithms, or logs, are used in many applications and explain much about how we perceive the world. The world has such extreme ranges that only logs make it possible to deal with them. We perceive the world in a way that is logarithmic in nature. Our eyes, ears, touch, and sense of smell all behave in a logarithmic, not a linear, manner. We even think logarithmically. We use logarithms to solve equations when the exponent is the unknown. Logarithms are an inverse operation of powers. So, to understand logarithms, it's important to first understand inverse operations. Recall from prior math courses, addition and subtraction are inverse operations of one another. 5 plus 4 equals 9, and 9 minus 4 equals 5. Multiplication and division are inverse operations of one another. 7 times 4 equals 28. 28 divided by 4 equals 7. Powers and roots, respectively, are inverse operations of one another. 10 to the second power equals 100. 100 to the 1/2 power equals 10. Remember, the denominator of a fractional exponent represents the root. Solve the following. Discuss the strategies that are being used. 2 to the x equals 64. 8 to the 6x equals 512, 3 to the x minus 1 equals 18. Did any equations give you more difficulty than others? Why? Here, we can rewrite 64 as 2 to the 6th power. Since they have the same bases now, we can set the exponents equal to one another, so x equals 6. Here, we can rewrite 512 as 8 to the 3rd power. Since they both have a base of 8, we can set the exponents equal 6x equals 3, or x equals 1/2. Over here, we have 3 to the x over 3 to the 1st power equals 18. Now what? None of the strategies for solving equations that we know of can be used to solve problem C. That doesn't mean that we can't solve it. Instead, it leads us to the next operation that we will study. Let b be a positive number that does not equal 1. The logarithmic function with base b, denoted by log sub b, is defined by log b of u equals v, and b to the v power equals u. For example, 3 squared equals 9, or log base 3 of 9 equals 2. Notice that the base of the exponent and the base of the logarithm are the same. So this 3 is the base of the exponent, and the base of the logarithm is right here, 3. The exponent becomes what the log is equivalent to. The three equations below are all true and can be written interchangeably. Log base 4 of 64 equals 3, 4 to the 3rd power equals 64, 64 to the 1/3 power equals 4. Let's practice relating these three equations to one another. A good method of doing this is to start here. 4 to the 3rd power equals 64. If you remember this little circle of arrows, that helps get you to this next equation here. 4 to the 3rd equals 64. Then to go from this equation to this equation, you just move the exponent to the other side and use the reciprocal. So instead of 3, it becomes 1/3. Write the other two equations. 3 to the 4th equals 81. Alright, so to get from 3 to the 4th power equals 81 to this equation here, you swap the exponent to the other side and make it the root. So instead of 4, it becomes 1 over 4. That's how you get 81 to the 1/4 power equals 3. Now to get to this log form here, I like to write log, and then I'd use the same base, 3. Then I tend to write the equal sign, and I write the exponent on the other side of the equal sign, and then I write the number that's on the right side of the equal sign here, right there. That way it's 3 to the 4th power equals 81. That's how I do it to remember what order they go in. Write the other two equations. Here we have 5 to the -2 power equals 1 over 25. So first, let's write that same base, 5, equals, and then we move this exponent to the other side, but we use the reciprocal. So instead of -2, it's -1/2. Now to get the log form, we write log, then use the same base, 5. I write the equal sign, and I put the exponent on the right side, and then I write 1 over 25 right there. All right, over here we have 4 to the -3 power equals 1 over 64. So we'll write 4 equals 1 over 64, and then we just move the exponent over and take the reciprocal, negative 1/3. I write log, same base, 4, write the equal sign, and then I write the exponent. Then whatever's over here, I put right here. So log base 4 of 1 over 64 equals negative 3. Or you could say 4 to the negative 3rd power is 1 over 64. And there you go. Write the other two equations. All right, so we'll write 7 to the 3rd power equals 343. And then writing the next equation is easy. You just swap the exponent over and use the reciprocal. All right, over here, we have 5 squared equals 25. And then 5 equals 25 to the 1/2 power. And there you go. Write the other two equations. 6 to the negative 2 power is 1 over 36. 6 to the negative 2 power is 1 over 36. Then we just swap the exponent, so 6 equals 1 over 36 to the negative 1/2 power. Swap the exponent over, use the reciprocal of it. All right, over here we have 3 to the negative 3rd power equals 1 over 27. And then the other form, we have 3 equals 1 over 27 to the negative 1/3 power. And there you go. Base 10 logarithms are called common logarithms or common logs. When the symbol log is used without an indicated base, it is a common logarithm using base 10. So here, write the other two equations. We could write 10 equals 10,000 to the 1/4 power. We've just swapped the exponent over and used the reciprocal. Or we could also say log base 10 equal sign, then I write the exponent over here and 10,000 here. So 10 to the 4th power equals 10,000. Or you could say, what power do you raise 10 to get 10,000? The answer is 4. And this is how you write it. Log of 10,000 equals 4. You don't have to write base 10. You don't have to include that. Write the other two equations. All right, so I can write 10 equals 1,000,000 to the 1/6 power. We can also write log base 10, but remember, we don't have to write the 10. So log base 10, then the equal sign, the exponent is 6, and then we write the 1,000,000 right here. So this is log base 10 of 1,000,000 equals 6. Over here we have 10 equals 0.01 to the negative 1/2 power. We just move the exponent over and use the reciprocal. Or we could write log base 10 equal sign. I write the exponent -2, and then I write 0.01 here. So once again, we don't have to include base 10 for this common log. And there we go. Write the other two equations. All right, so it might help to write the 10 here. So you can see 10 to the 5th power equals 100,000. 10 to the 5th power equals 100,000. And then for the other equation, just swap the exponent to the other side and use the reciprocal. So 10 equals 100,000 to the 1/5 power. Over here we have log base 10. So 10 to the negative 4th power equals 0.0001. And then swap the exponent. 10 equals 0.0001 to the negative 1/4 power. And there you go.